right, there's one more thing with square roots I want to talk to you guys about, and that's rationalizing square roots. So we don't really like roots in the denominator. So rationalizing means to clear out the root or radical in the denominator. Okay. So in math, as I'm sure you've noticed, we like to have things written nicely at the end. So for instance, we always simplify our fractions, right? We do things like combine like terms or clear out parentheses. We don't like to have things written too messily. And one thing that we don't like is we don't usually like to have roots left over in the denominator. So we will often rationalize those denominators to have them just look a little bit nicer. So let me show you how to do that. All right, so here are two examples, and we can see you have roots in the denominator, and there's, at least for the first one, not really much else I can do just yet, right? So if I look at this first one, I have a root 6. Root 6 is not going to clear out perfectly. If root 6 or if 6 was a perfect square, it'd be easy, right? If this problem was, for instance, as a side note, like if this problem was 15 over root 16, then I could just write this as 15 over 4 and I'm done. I don't have to rationalize anything. But this root doesn't come out to be perfect. So what you do is you multiply by that same root again. But you do it in the top and the bottom. So whatever the denominator is, that's what I'm using to multiply. And then we're going to simplify. So in the top, I just have 15 root 6. If I have a number outside and a number inside the root, I don't actually multiply them together. I just leave them separate. Here, you end up with root 6 times root 6, and you can combine those together. So this becomes 6 times 6. So I can only combine the insides together, not the outsides. So I have 15 root 6. Now, 6 times 6 is 36. And notice what happens is that once I go ahead and simplify, well, square root of 36 is now 6. So you end up canceling out that root in the denominator. And you can really just jump right to that answer if you notice it, right? Those two roots are going to cancel because I end up with a 6 squared there. So that bottom piece is going to cancel out. If you can simplify your radical anymore, you would do that. So root 6, I can't simplify this. So I'm done there. And you would also want to look here to see if you can reduce your fraction. Now, with 15 over 6, I actually can divide these both by 3. Notice that when I'm working here and I'm simplifying, I'm just doing my outside numbers. I'm not touching under the root. So I divide those both by 3, and I have 5 on the top. I have that root 6, and then I have 2 on the bottom. Now, for my second one here, I'm actually going to do this one a little bit different than how you sometimes see it. So if I see a square root in the denominator, I think that's just the easiest thing to do is to just use that square root and rewrite it. Now, I know that square root of 8 can be simplified, right? Because it does have a perfect square factor. So some people like to do that first. They'll go in, they'll look at the different factors, they'll find the perfect squares, and they'll start cleaning that up first. I think it's sometimes easier just to go in and rationalize. So I like to do that first. So this leaves me with 12 root 8 in the numerator. And then what happens is, remember, those roots are going to cancel out. You end up with the square root of 8 times 8. Which is the square root of 64. So you're just going to get an 8 in the denominator. And then now for me, now I like to simplify. So I'm going to simplify a few different things. So I am going to work with that root 8 probably first. So that would be the same thing as the square root of 4 times the square root of 2. So it becomes 2 root 2. So So this becomes 12 times 2 root 2 all over 8. And here, when you multiply, you just do the outside numbers. So 12 times 2 is 24. So I have 24 root 2 over 8. And now you do also want to simplify and reduce that fraction out front. So again, you're just kind of doing one little step at a time here. I see something else that I can simplify. 24 divided by 8 is just 3. So my final answer is 3 root 2. Okay, so we're just take our time here. Again, some people like to simplify first. So you could have simplified this first as 2 root 2 and maybe reduced your fraction a little bit there before you started rationalizing, and that is fine too. I personally just kind of like to rationalize and simplify at the end, but either order, you'll get the right answer. All right, let's do another example that's a little bit harder. Now, this one's a little trickier. It's not just one number in the denominator. And when this happens, we use something called conjugates. So conjugates, there's different kinds of conjugates in math, but conjugates for roots would be root A plus root B and root A minus root B. Okay, so you have this piece in the middle where it's the same exact thing, but your positive changes to negative or your negative changes to positive. So these are your conjugate roots. And again, there are other kinds of conjugates too. We have conjugates for complex numbers as well. So you may have seen this definition elsewhere. And if you haven't, that's okay. But basically with conjugates, it's the same exact numbers, but the inside sign changes. So what happens here, let's say I have 5 plus root 3, then the conjugate is 5 minus root 3. So it doesn't matter if my first number is a whole number or not. It's the same idea. And when you have a more complex number like this, we're going to use the conjugate to help rationalize instead. So I'm going to take that 7 over 5 plus root 3. And what I'm going to do is multiply by 5 minus root 3 in both the numerator and denominator. And that's how you get the root to cancel. If I use just the root 3, I end up multiplying and I'm still always going to have a square root left over. So by using the conjugate, you actually will get those roots to cancel in the denominator. And I'll show you right now how it works when we multiply or FOIL everything out. So remember too, that if you have more than one thing in a fraction, they're all sort of stuck together. So you can think of it like this. And you are going to distribute. So I'm going to do 5 times 7, which is 35. And then that's 7 times negative root 3. And remember, we don't multiply outside and inside numbers. So that 7 stays on the outside and the 3 stays on the inside. In my denominator, we do the same thing, but you're going to have to distribute twice or FOIL here. So we have 5 times 5, which is 25. 5 times negative root 3, so negative 5 root 3. Here I have a positive 5 and a root 3. And again, I like to write my whole numbers first and the roots at the end. It doesn't matter. And then here you have negative root 3 times root 3. So cleaning this up, I have 35 minus 7 root 3 in the numerator. I have a 25 here. Notice that negative 5 root 3 and positive 5 root 3 are going to cancel. Because they're the same kind of root, we can combine them. And negative 5 and positive 5 give you 0. So those are going to cancel out completely. And then what happens here, I have root 3 times root 3. So you have root 3 times 3, and that little piece there becomes the square root of 9. And the square root of 9 is just 3. So you get this canceling idea happening in that last piece. So I actually have 25 minus 9 in that denominator. And that's going to put it over 16 there. Oh, sorry, I made a mistake when I was writing. Sorry, guys. The answer here is 3, not 9. I don't know why I wrote that. That looks better. I kind of paused, so I knew something didn't look right. So here we have square root of 3 times 3, which is square root of 9, or just 3. I should not have written the 9. So it's just the 3 coming down here. Sorry about that. And then 25 minus 3, that looks better, is 22. So this would be my final answer here. And notice that I have gotten rid of that root in the denominator, which was my goal in rationalizing. So when we're rationalizing the denominator, excuse me, we just want to clear out that root in the denominator. We don't like it. So we're going to go ahead and clear that out. And the same thing would be true. So I'm just going to do a simpler example here, but let's say you had something like the square root of 25 over 3. Okay. Now we know from the quotient rule that you can split this square root of 25 over square root of 3, and the 5 clears out, but the 3 doesn't. So sometimes if you have something like this, you still want to take it further, always keep simplifying. I don't have any conjugates to worry about here, so I'm just going to multiply by that same root 3. And we end up with 5 root 3 up top. And remember, those two roots are going to cancel, so we just have the 3 in the denominator. So even if you start like this, you still want, this still counts as having a root in the denominator. You want to keep going with that and simplify until that root is fully gone.